Now I want you to think about what you know about convection and think about how it affects the Earth. So we know that the asthenosphere is not a solid. It's partially melted, so we're going to call it a liquid. We also know that it's cooler near the top and gets hotter near the bottom. Those are the criteria for convection. So it's not a solid and it is unevenly heated. So let's review up here. Convection is a way that heat moves around. It is a method of heat transfer. Convection is the process of blank dense or hotter materials floating and blank dense or cooler materials sinking. Hopefully you remember that hotter materials are less dense, which causes them to float upwards, and cooler materials are more dense. So the next thing I want you to do is use some color. If you want to color the crust brown or gray, that's fine, but let's color the arrows for sure. Since we know it's hotter at the bottom and cooler near the top, this hotter material is going to become less dense and rise. So let's color that red. I need to get my red here. Okay, sorry about that. So let's color the up arrows red to show that they're hotter material rising. So we're going to color those red. Please do the same on your notes. And then we're going to color the down arrows blue because that's areas those are cooler areas that are sinking. Okay? And whenever you think about convection, that's the best place to start. Figure out where it's hotter and where it's cooler so you know where material's rising and where material's sinking. And now we need to finish the convection cycle. So change your color to black or just regular pencil. And as this material rises, it's going to hit the solid crust. And what's going to happen is, like in the video you saw, it's going to spread out in both directions until it cools, and then it will sink again. Now these down arrows are going to do the same thing. They're going to sink down until they hit the more solid mantle, spread out, and notice I've just made a circle, basically. Okay, this one is also going to spread out to there. This red one will rise and spread, and I'm just going to have one go right off of my page. And I'll finish this one as well. This will sink. So basically, once you can figure out which arrows are going up and down, you just kind of finish the circle. And that's how the convection cell works. The next thing I want you to look at is how this would affect the crust. Now, before we look at that, I want you to think about a boat floating on a liquid layer. So the crust is solid, but it is on kind of a liquid layer. So if we think of this, so let's say this is just a boat, and let's say that this water is a river. And let's imagine that our river is going this direction. If the water is flowing to the right, which way will the boat get carried or dragged? Hopefully you realize the boat's going to go the same direction the water is going. All right, let's go back to your notes now. Okay, I'm going to change colors. So if this convection current, remember these are huge, many, many miles long. If this liquid rock, semi-liquid rock, is going to the right, it's going to drag the crust above it, whoops, to the right. Oops, I don't want to be yellow. Okay, but notice this current isn't going to the right, it's going to the left. So if this material's going to the left, it's going to drag the crust with it. So notice the crust gets pushed and pulled the same direction that the current below it is going. So these arrows are going to be parallel. They're basically going to match. And hopefully you're going to see, once you put all your arrows in, that there are places where the crust is getting squished together, and there are places where the crust is getting pulled apart. And we're going to be talking more about what happens in these areas in our next unit. So, another one to look at here. Let's look at this picture. These green squares represent pieces of crust, and you can see the convection cells underneath them. What I want you to predict is which way is A going to move, which way is B going to move, and which way is C going to move. So look at the convection currents below each piece of crust and make a prediction, and then I'll show you the answer in just a second. All right. Let's see if you guessed correctly. Notice the pieces of crust go the same direction as the current below them. It's kind of like a conveyor belt. You can watch that one more time. Maybe. Let me refresh the page. So notice sometimes they collide and sometimes they get pulled apart. This actually represents a mid-ocean ridge where the crust is pulled apart and lava is filling the gap. All right, so make sure your notes are complete and continue on with this lesson.